Hey everybody, Lars here. Wanted to jump on really quick tonight and do the second review video for Unit 2 because like I always say, I try to get you all your resources for a unit a week before the unit is over. I just went back and reread the syllabus, and Unit 2 ends pretty much a week from today, next Sunday. I know it's summer. We go so quick in summer, it's bizarre. It feels like we just started. We did just start, and already we're talking about the end of Unit 2. But I want to get you this video. It's a pretty important one, too. In the past, I've run super long with it, but I'm going to try and be good with it tonight. Again, though, I'm battling back and forth because I don't want to not cover something because it's important, and I want you to see it, and I want you to understand it. So usually what I do is we'll go through some simple loops. I'll show you the range function. Then we'll solve a quick problem. Then I want to show you 3 separate examples of different kinds of loops and different things that we do with looping as we go along. So I'm going to get started right off the bat. I'm going to start from scratch and just create a file called, let's see, new file. And we will call it loops.py. Play with loops. All right, so really fast. I'm going to create a list. You're familiar with them because you did them in the first half of the unit. I'm just going to call it my list. And I'm going to make it equal to piece of cake. 5 items, even numbers. Okay? So now, what if I wanted to do something? What if I wanted to perform a task where I wanted to do something to every one of the items in that list? What I'm going to do is I'm going to iterate over it or loop over it and create a construct in programming that allows me to pretty much regard every item and do something with it. So I'm going to say for. Now you can see that for is turned purple. Idle turns it purple because it's a keyword. And I will say for I in my list. All right, 2 things. 1, if you have any experience with Java or C++ or C or anything like that, that's not the way you're used to doing a for loop. You're used to setting up the initial variable, setting up a condition, doing an increment or a decrement, blah, blah, blah. We don't do that in Python. Python is simple. You have a list. You set up a for loop. It does something for everything in the list. End of story. And later on, when we get some facility with it, we start using it, you're going to realize, hey, this is the way iteration should be. That things that are going on in C++ or Java, maybe it's a bit more convoluted than it has to be. Anyway, I digress. Another thing, you see that colon, that means I'm starting with a new block underneath it, very similar to what we do with if, then, else. So what I'm going to do here is I'm just going to print it. I'm going to say print I, so that when first I've got to save it. Let's see, do I have a Unit 2 folder? Python Data Science. Summer 2017. I do have a unit. Look at that. Strings list is there. I'll call it loops. Loops.py. So now when I save it and run it, you see I just print the items in the list. Okay? Now, don't think that that's the only thing you can do. You can create a code block. So if I want, I can print the list, and then I can print the squares, and then I can, I don't know, print a divider thingy. So I can do that. Look at that. Okay? For every item in the list, you ran through and it ran that code block. So first time through, I is 2. Print 2 square, 2, 4, then my little stars, boom, back to the beginning. I is now 4. Print I squared, 16, 4, 16, 6, 36, 8, 16. You can see all the way down the line. It does that, okay? That's, that's the simplest example I can give you. That's iteration. In Python, we iterate over a list. It's just a way to loop, to go up and down. You can see why it gets the name loop. I is 2, you go down, and then you loop back up, make it a 4, loop back up, make it a 6, loop back up, make it an 8, until you get to the end. When there's nothing more, then you drop down to the bottom. And you can see it will just print that once, because it's out of the loop, okay? All right, so that is the simplest way we can consider iteration. But there are some times, and I'm going to actually save this code like that. So you can have it all when we're done. I'll put loops.py up in Sakai for you. So sometimes we know how many times we want to loop, though. Sometimes we know, hey, I want to loop 10 times. Hey, I want to loop 20 times. Sometimes we want to go back and kind of do things the way you did in the past if you're an old programmer. But if you're a new programmer, sometimes you really just want to do something 10 times, and you want the numbers 1 through 10 to do it. So what we do with that in Python is we use range, and you've read in the slides about the range for I in, I'm going to say range 10, and just print that. And then I will print I. So that when we run this, you can see it prints 0 through 9, okay? I said range 10 there. It gave me 10 items, but we start counting at 0, so it ended at 9. The real reason is this. This is shorthand, okay? What I'm really saying here is this. You'll see if I run it again, I get exactly the same thing. Because with the range, that's where I want to start, 0. But it's also the default, so I don't have to put it there. And if I don't put it there, the program will assume 0. 10, this is a range in Python. 10 is the first thing I don't want. And 1 is the increment, okay? I don't need it because 1 is the default. So if I ran it without it, I still get 0 through 9. You know what? 0 is the default. So I still get 0 through 9. But if I want to start changing things, let's say I want to start at 1. And I want to go to 11 because I want 1 to 10. Well, then I get 1 to 10 that way. See, 11 is the first thing I don't want. Start at 1. Okay? Now let's say I wanted a countdown. Let's say I wanted to start at 10 and go down to 0, but really 1, because 0 would be the first thing I don't want. And then negative 1. Well, then I get a countdown. Okay? Because negative 1 tells me to go backwards. That's the 0 increment. Okay? Last thing I'm going to do with range, I will start at 0. I will go to 101, and I will increment by 5. You don't have to go ones. You can go anything you want. I just did the multiples of 5 there. Okay? You can increment by however many you want and get those numbers. All right? Now, and it's logical to think so, you may be thinking range creates lists. It really doesn't. In Python, a thing, and you read this in that little behind-the-scenes thing in the slides. In Python, range is something called a generator. It's just generating the next number in the sequence. It saves memory. It's a way to save memory. You can get a list of the multiples of 5. Well, what you have to do is cast it. You'd have to cast the range function into a list, and you could do it that way. Kind of a little bit beyond the scope of what we're doing here today. I just want you to see range, because a lot of times when you do a loop, you want to generate the numbers with range and then use the numbers that you've generated as far as doing a loop. It's not as easy as our first case. Okay? All right. How am I doing time-wise? 8 minutes? Not sure. Shabby, crabby. I want to definitely check on time because I want to get you done in a decent amount of time today. 1, 2, 3. Okay, now, what we're going to do next is we're going to solve a problem. Okay? We're finally there. We've got simple data. We've got arithmetic. We've got decisions with if, then, else. We've got lists, we've got strings, we've got sequences. Now we've got iteration. We can iterate over things. Now we can start solving some problems. So what I usually do is I say for the first 300 natural numbers, how many of their squares are greater than 50,000? Okay? Now think about that. How would you solve that problem? Okay? You would have the first 300 natural numbers, 1 through 300. You would square them, and then you would look at each one and determine which ones were greater than 50,000 and save them or count them to figure out how many there were. But in a programming context, how are we going to do that? So I think I know how I'm going to do that. I'm going to say for I in range. I'm going to go from 1 to 301. 301 is the first thing I don't want. And just to make sure I'm in the right place, I'm just going to print them right now. So when I run this, there we go. I get 1 through 300. I'm going to trust it started at 1. Did it? Yes, it did. All right, so I've got 1 through 300. All right, so that's pretty cool. But I don't really want that. What I really want is the squares. So instead of printing 1 through 300, let's print their squares. All right, now I've got their squares, and I'm printing that, and I can see quite a few of them are greater than 50,000, so I'm going to have some results here. Some are below, though, and I go up there. Let me go up here to the beginning. And, oh, no, that's the regular numbers. Here we go, 1, 4, 9, 16. All right, these look like squares to me, okay? All right, So now I have the squares. So now I have to determine how many are greater than 50,000, right? But I'm going to do a little something here. I'm going to get a blank list. And this is where lists come in handy. Remember what I said, empty bookshelves. And instead of printing them, what I'm going to do is I'm going to say squares dot append, and I am going to create a list with all of the squares in it, and then I'm going to print that list. All right. So now when I run it, you can see there's a bracket up here, there's a bracket down here. This is a list, but it's got the 300 squares in it. But this is the point. Now I have those squares in a list. What can I do with a list? I can iterate over it. For I in squares, if I is greater than 50,000, print I. Boom. Let's go make sure I'm right, though. It starts at 5176. So if I come up here and eyeball my list, I see 5176, and the one before it was less than 50,000, so I think I'm in pretty good shape. Okay? But there's one last thing we want to do. For the first 300 natural numbers, how many of their squares are greater than 50K? So how many of these are there? There's a decent amount, but I'm not going to sit here and count them. I want my computer program to do that. So I'm going to show you something called a counter. I'm going to create a variable. I'm going to call it count. I'm going to make it to equal. And every time I have a result that's greater than 50,000, I'm going to make count equal to count plus 1. I'm going to add 1 to count. And then when I'm done with my loop, I'm going to print. Well, actually, no. You know what I'm going to do? Watch this. This is a better way to do it. I'm going to add 1 to the counter, and then I'm going to print I, comma, count. So I will print the item, and then right next to it, I'll print its number. Aha! That's very clever. Let's see if it works. And look at that. So now I have the number. That's the first one. That's the 16th one. All the way down to the end, 90,077. So I've answered the question. For the first 300 natural numbers, if I look at all their squares, there are 77 of the 300 that are greater than 50,000. Okay? Now, we're learning. There are simpler ways to do what we just did. If I wanted to, I could have done it up here, blah, blah, blah. But I don't want to do that. Oh, what I do want to do is one more thing. In the way of a counter, I'm also going to teach you about a little thing called an accumulator. Counters count. Accumulators accumulate. So what do I want to add? If I want to accumulate things and add them up, I don't want to do 1 because that's going to give me a counter. I want to do I because that's the actual item itself. Okay? So now I will accumulate things as I go along. And there we go. So now when I get to the bottom, there are 77 of the squares that are greater than 50K, and if I added them all up, that would be the number, 5,323,000 something. All right? So now think about what we just did. Okay? We're actually doing something now. We're actually solving problems. And we're thinking like programmers. And we used lists, empty bookshelves. I wanted squares, so I stuck them in there. I printed them out. Then I went over those squares to see which were greater than 50,000. Because you'll see in a lot of these problems, and you're going to see in the Euler problem that we're going to tackle down the road, that most often times things that you're asked are really 3 or 4 different problems when you break them out and you compartmentalize them. Okay? So regard this piece of code, know what's going on here. This is important stuff, okay? We're using lists. We're using for loops. We're using ifs to judge things, blah, 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 okay? You now know how to do a counter. You now know how to do an accumulator, all right? Be happy. All right, good, good, good. All right, we're going to save that, and we are making good progress, I believe. There are 3 special things I want to show you. The first special thing for I in range 3, print I, comma, outer, for j in range 5, print I, comma, j, comma, inner. What's that going to do? What is that little blurb of code right there going to do for us? Let's find out. Hope it runs right. All right. What you have right there is called a nested loop. It's a loop inside of a loop. And as you can see here, my first time through the loop, I print outer, and then I run the inner loop. So you can see the outer run is number 0, and then the inner loop runs. It goes inner 1, inner 2, inner 3, inner 4, and then it ends. And then when it ends, whoop, we go to the top of the outer loop again. So that becomes 1 outer, and then 1 0, 1 1, 1 2, boom, 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 boom. Okay? 3 times on the outside, 0 through 2, and 5 times on the inside, 0 through 4. Now, you're probably asking, oh, what a nifty little parlor trick. Who really cares? Why do I need to know that? You need to know that because when you get more sophisticated with your programs and reading data, that is how you're going to navigate data in a grid. That is how you're going to navigate rows and columns. Because think about it. Your outer loop would be your row, and your inner loop would be your columns. 1, 2, 3, 4, 5. Then I'm done. I want to go to the next row. Increase your outer loop. 1, 2, 3, 4, 5, and regard all of those columns. This, by using nested loops, is how we regard grid data, or data that's stored in tables. Okay? So it's important, and I want you to be able to see how you can run loops inside of loops. So if I have an outer loop and then an inner loop of 5 with an outer loop of 3, loop, I'm going to run that 15 times. Okay? All right, nested loops in the mud. Now, the next thing we're going to look at is a cool one. We have been, let me get some space here. We have been dealing with the range function. We have been dealing with lists where we know how many things are in there. So we know we're going to loop 10 times. We know we're going to loop 300 times to get our squares. We're going to do all that. These are all called in programming definite loops. I know how long they're going to be. What if I've got a situation where I want to loop until a certain condition is true? So I don't know when that condition is going to be true, but when it is, I need to stop looping. Okay? That's called an indefinite loop. And the way we do an indefinite loop is with something called while. And I'm going to show you. First, I'm going to start off doing it this way. You can see idle makes it orange because it's a keyword. And I'm going to say while char is equal to y. Stay in this loop. And then what I'm going to do is I'm going to print loop. And then I'm going to ask the user for another letter. I'm going to say char equals input. Do you want to continue? Question mark, colon, space, boom, boom. Okay? So what's going to happen? Think about that code. First of all, I set the variable to y. Then I see if char is equal to y. It's true. So we go into the loop. I print loop. And then I say char, input, do you want to continue? Now, if I give it a y, I will come up here and it'll say, is char equal to y? Well, it sure is. Then I'll print loop again. Okay? And I'll keep doing that as long as I give it a y. Then, one time it's going to run and I'm going to give it an n. So char will equal the string n. And then it'll say, while char is equal to n, will it run? No, it'll skip to the bottom. Here, let me print something here at the bottom. I made fun of the end the other day, so I'll just say bottom. There we go. Okay, so let's run this bad boy and see if it works. Okay, loop, do you want to continue? Why, yes. Yes, I do. I love to loop. All right, do I want to continue? N, no. All right, so it printed bottom and it got me out of the loop. That's 6 times we ran in that loop. Okay? Look at me run it again. Yes, yes. That's 3 times. You never know how many times you're going to go through that loop. It's called an indefinite loop. Also, in this particular case, it's also called what we call an interactive loop because you're actually changing it in the you're changing things in the middle of the loop. So it's interactive. The user is actually changing some of the output. Okay? Some people do char. You'll notice that there's a little bugaboo about it. I can say yes, 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 and then I don't have to give it an n. I just give it anything that's not a, y, and it works. So some people will do not equal to n, okay? So I make it equal to y. Is it not equal to n? That's true. So then do you want to continue? Yes, yes, yes. But now I can give it z, s, d, blah, blah, whatever I want. It's looking for the n, and then the n will get it out. So you have your choice with while loops. You can make it not equal to n or equal to y as far as that's concerned. Okay? Now, that simple little thing you just saw, that while loop, that while loop is around every video game you've ever played in your life. There is a big master while loop that all video games run in. And when you get to the end and it says game over, do you want to play again? Yes or no? That's what you're doing. It's a while loop. Trust me, I know, I'd write them. Okay? That's all that game is. It's a big while loop. If you say no, you go out and the game ends. If you say yes, you start over. You go right to the top and you run through that loop again. Now, there's game loops inside, and it gets a little more complicated than that. But at the end of the day, it's not that complicated. Most video games are a big while loop. Okay? So you're going to see a lot more of this coming up. All right. I am doing really, I'm keeping down on the chatter. Look at that, 22-bit. Look at this. I'm going to wreck it by talking about it right now, but goodness gracious, the discipline needed to keep my big mouth shut is enormous. Oh my goodness gracious, it's so hard not to just start talking about the hockey game tonight and riding my bike down Route 27 and almost getting hit by a bus and all the things that happened today. Keeping my mouth shut is not easy. All right, there's one more thing we want to do. It's actually fun. The list is a list. It's got 2, 4, 6, 8, 10. I'll say 300. 23, 40, it doesn't matter. You'll see why in a minute. Okay, I don't want you to think these spaces have anything to do with the price of tea in China, so I will get rid of them. All right, I have a list. What you have been seeing for I in the list. Yeah, because that'll work. Spelling things out like I'm Stephen King instead of writing programs. For I in the list, print I. You know what? I'll even do an accumulator. U plus I. Print cum. Because I'm smart, I know that I have to set the variable equal to 0, so when I get here, something already exists. And look at that. So when I run this code, it's going to consider all of these items in my list, and it's going to add them all up, and at the end, we are going to print them. Yay, why did that go all that? Oh, what are my nuts out? I don't need to do that. I will get rid of the print line. I don't need to print them. All right, 433. Is that correct? Let's cheat and find out. I can just use sum. And this is what you're going to do after you learn. Because no one does your own accumulator after a while. Yay, that's right. Now, well, you know what? What I just said, it's not true. Because there's a time where you do want to run your accumulator. You know when that time is? Now! Because we are going to look at something called a Sentinel loop. What you've been seeing is regular old iteration for I in the list. And I go through 2, then 4, then 6, then 8, all the way down till I get to the end. Come hell or high water, I always go to the end. But what if I want to stop if I get to a certain number? In computer science, if you're watching for something to happen, it's called a sentinel. And let's call the sentinel 300. And let's say I want to add up all the numbers in this list until I get to 300. And then I want to stop because I'm only interested in the numbers up to 300. In computer science terms, 300 would be my sentinel. Okay? So how would I do that? How would I go about doing that? Let's first get rid of this. Accum 0, okay, for I in the list, okay. What do I do? I'm going to get rid of this print for the time being. I add it to the accumulator. Okay, well that would be all right for the first 5 numbers, but then when I get to 300 and add it to the accumulator, I got to do something else here. The first thing I think I want to do because I want to see if it's the accumulator. So I'm going to say if I is equal to 300, then do something. But what would I do? Maybe I don't want to do that. Maybe I want to say if I is not equal to 300. There, that kind of makes sense for me. Because if it's not equal to 300, then I'll add it to the accumulator. Because what I want to do is keep adding these numbers until I see the Sentinel. Now, if I is not equal to 300, what if that's true? Well, if it's true, that means it's 300. And if that's the case, it means we found the Sentinel. It means we've gotten to the point that we're looking for. We're looking for that every time through. So what do we want to do? We want to stop. We want to stop. We want to get out of this loop. And there's a way you can do it. There's a keyword in Python called break. Break will break you out of the loop that it's in. Okay? This if-else decision structure, that's not a loop. That's not something you break out of. This break will break out of whatever loop it is in, which is this one, the for loop. If we were in a nested loop and the break were inside the J, it would only break the J. It only breaks the loop it's in. All right? But in our case, and we'll trace through it really quick, I have the list 2 through 56. Accum equals 0. For I in the list, it's a 2. Is it not equal to 300? Yes. So I add it to the accumulator. Go back to the top. Grab the 4. Is it equal to 300? No, it's not. So that's true. I add it to the accumulator. Boom, boom, boom. I go down the line until I get to 300. Now, if 300 is not equal to 300, that's false. That's false. I found the accumulator. So I'm not going to run this. I'm going to go to the else. And the else tells me to break. So I break. An accumulator is only equal to the first 5. We got 6, we've got 12, we got 20, 30. So it should only be 30. Let's find out. Let's find out. And it is. Phew. Okay? That's called a Sentinel loop. Sometimes we use them when we're looking for a certain number. Keep adding things up until you reach a certain number and then go perform another action. It doesn't have to be break. It could be something else. But here I want to show you break. There's basically this little segment right here has 2 different birds that I'm killing with 1 stone. One, I want to show you what a Sentinel loop is and make you aware of the term. And if you ever hear it, you'll know what's going on. Number 2, I want you to see break. Because sometimes you want to break out of loops, and that's the way you would do it. You only break out of the loop that you're in, though. All right? All right. You know what we're going to get? We are going to get a real, honest-to-goodness finale. Is all that code there? And you have no worries because I'm going to put all of this code up on Sakai for you. Look at this. Wow. Oh, my loop. Do I want to continue? Yes, yes, yes. Z. Aha, I got to put N. And then I get out. And then it tells me 30. So, wow, look at all this. Let's go up here. All right, what did we do? We started playing with just regular loops. We took a number and then we squared it. And we did that for our little 5 loop, and then we printed bottom. And then we played with ranges where we left off. We did the multiples of 5. Then we solved our problem. We created a list with all the squares in it, so that's got 300 squares in it. And then we did our math. We found out what was greater than 50,000, what number it was, and then we accumulated them all. So when we got to the end, we saw there were 77 of them. Pretty decent. We looked at nested loops. So we saw an I, and then we saw a J, and then we saw all of that. We looked at while and interactive loops, and then we looked at Sentinel loops, and we ended up with that 30 because we were down here at the bottom with our Sentinel loops. Okay? All right. All right. I think, let's find 30. Look at that! 30 just as I click it. Very nice. All right. Tonight, unfortunately, I am going to clobber you with announcements because this represents all of your resources for Unit 2. You've got your slides. You've got your Zell readings. You've got your review videos. Tomorrow night, Monday night, I will release the assignments. Okay? So you'll have the 2 assignments for Unit 2. Tomorrow night, you'll have a whole week to work on them. All right? There's also going to be a 3rd video, but you're going to get it later in the week where I'm going to play around with Project Euler and teach about what Project Euler is, and we're going to go solve one of the problems there. I think I gave it to you in the slides. It's problem 6. So we're going to use our tools that we have now. Lists, decision-making, simple arithmetic, iteration, and we're going to start solving some problems. Because now's that magic moment. Now's the time where you're going to have enough in your toolbox where we can start solving real problems. And think about what we just did in the last half hour. There's some, slightly data sciencey stuff in there. We got a list. We found all the squares. We regarded all the squares and made a decision depending on how big it was. Boom, boom, boom. So we're, gotta learn to walk before you can run. But we're getting there. We're doing some things. All right? In case you didn't know, all of the information for the midterm project is now up in your resources. It's not due till July 11th. That said, that's a month from today. Today is June 11th. It will creep up on you, so do not sleep on that, all right? Like every weekend, take 2 hours. Python the hard way, MIT lectures, Code Academy, so that every weekend you do it, you keep notes when you do it, and then the paper will write itself. What is it, 4 pages, 5 pages? You do 2.5 pages, then you double space it. For goodness sake, it'll be a piece of cake, all right? Don't give me bullet lists. That's not a paper, all right? Don't give me pictures. That's not a paper. You got to write a paper. It's got to be expository. You have to explain things. Part of computer science, and we're going to get to this, is communication. Part of science is communication. A huge part. You've got to learn to write about this stuff. You've got to learn to write about technical things. So that's why the midterm project is actually a tiny little paper. All right, we should be good. I'm going to get you the assignments tomorrow night. I'm going to hopefully get you the Euler video Wednesday, Tuesday. That doesn't impact you getting your assignments done, so I don't mind getting you that a little bit later in the week. I do want to make sure you have all the resources needed to do your assignments with about a week left to go in the unit, and that's actually tomorrow. So I want you to be okay, and I want you to be comfortable. Somewhere along the week, you will get grades because Hans graded all the programs. So I just have to get off my lazy butt and grade the quizzes and then put together my grade book and then send you your first round of grades. So hopefully that'll happen sometime early in the week when I find some time. So we're in the thick of it. We're getting it done. I hope you're having fun. It is fun. Learning to program is fun. So I'm going to get out of here. I want to keep this short, and I'm sitting here blabbing. You be good. I'll get you the assignments tomorrow night, and I'll be in touch via announcements, and then hopefully later in the week I get you that Euler. All right? Then you be good. I'll talk to you later. Bye. Let's see what we did. 33 minutes. Not the end of the world. Not the end of the world at all. All right. You be good. Later.